Welcome to section 4.2, amplitude and period. We have two objectives for this section. The first objective, find the amplitude and period of a given graph. When analyzing the graph of a trigonometric function, two key characteristics to identify are the amplitude and the period. These properties determine the shape and behavior of sine and cosine graphs. Amplitude. The amplitude of a trigonometric function represents the vertical stretch or height of the wave. It is found by taking the absolute value of the coefficient a in the general sine or cosine equation. So if we have y equals a sine of bx or y equals a cosine bx, the a would represent the amplitude. The formula for amplitude is amplitude equals the absolute value of a. If a is greater than 0, the wave follows its usual pattern. If a is less than 0, the wave is reflected over the x-axis. The larger a, the taller the wave. The smaller a, the shorter the wave. For example, y equals 3 sine x has an amplitude of 3, meaning the function oscillates between -3 and 3. Y equals 2 cosine x has an amplitude of 2, meaning the function oscillates between -2 and 2. Period. The period of a function is the horizontal length required for the function to complete one full cycle. It is determined by the b value in the sine or cosine equation. So back to our equations, y equals a sine bx or y equals a cosine bx. The b, which is usually the coefficient in front of the x value, will represent the period. The formula for the period is period equals 2 pi divided by the absolute value of b. If b is greater than 1, the function completes more cycles. It is compressed horizontally, so it's kind of squished together. If b is between 0 and 1, the function completes fewer cycles, meaning it is stretched horizontally. For example, y equals sine 2x has a period of, if we plug in 2 for b, we get 2 pi divided by 2, which equals pi, meaning it completes a cycle in pi instead of 2 pi. So this would mean that it is compressed. Y equals 1/2 x has a period of, well, b here is 1/2, so we'll take 2 pi divided by 1/2, which equals 4 pi, meaning the wave stretches and it takes longer to complete a cycle. So instead of completing it in 2 pi, it completes it in 4 pi. By identifying amplitude and period, we can accurately describe and graph trigonometric functions. All right, now we are going to graph trigonometric functions with negative exponents. So far, we've worked with trigonometric functions where the coefficients a and b have been positive. However, when given an equation with a negative b value, we can use the properties of even and odd functions to rewrite the equation so that b is positive, making graphing easier. Since sine and cosine have specific symmetry properties, sine is an odd function, meaning the sine of negative x equals negative sine x. Cosine is an even function, meaning cosine of negative x equals cosine x. We can use these properties to rewrite equations where b is negative. For example, y equals 3 sine of negative 2x would be equivalent to y equals negative 3 sine 2x. Since sine is an odd function, we pull out the negative sign and then rewrite the equation. Now, if we have y equals 3 cosine negative 2x as in example 2, this would be equivalent to y equals 3 cosine 2x. So in this case, since cosine is an even function, we can drop the negative inside the cosine function. So thus, we do not need to graph equations with the negative b values directly. Instead, we can just rewrite the function with a positive b value and then graph as usual. So here are some steps that I have provided for you for graphing trigonometric functions with negative coefficients. The first step is to check if b is negative. If b is negative, then we will rewrite the equation using the properties of even and odd functions to make b positive. For step 2, you'll then determine the amplitude and the period. So for the amplitude, we will take the absolute value of a. For the period, we will take 2 pi divided by the absolute value of b. For step 3, we will account for reflections. If a is negative, then we will reflect the graph over the x-axis. If a is positive, then we will continue with the normal properties of the sine or cosine graph. Step 4, we will plot key points. So we will identify the starting point, the peaks, the troughs, and the zeros based on the function's behavior. And then step 5, we will sketch the graph. So we'll draw a smooth curve, making sure it follows the correct period, amplitude, and reflection pattern. So by following these steps, we can accurately graph trigonometric functions even when they have negative coefficients. Okay. So let's spend the rest of this time graphing some trigonometric functions. So the first one here that we're going to graph is y equals 6 sine x. Okay, so let's find the amplitude of this function. Okay, so the amplitude is a, absolute value of a, and so that would be the absolute value of 6, which is 6. The period would be 2 pi divided by the absolute value of b, which is 1. So our period is 2 pi, which is the same period for the function, the parent function of sine. Okay. So the only difference between this equation and the parent function is that the amplitude is 6. So what we'll do is for sine, the standard equation for sine, all right, starts at 0 and then it goes to 1 at pi over 2 and then it comes back down. So instead of going to 1 at pi over 2, we're now going to go all the way up to 6. So my graph ends at 5. So I'm just going to place a dot above my graph just to signify where 6 would potentially be. All right, so my sine graph starts at 0, and then it's going to go all the way up to 6 at pi over 2, and then it's going to come back to 0, and then 3 pi over 2, and then 0. All right, then we can connect the dots. Missed that one. There we go. All right, so that is one complete cycle. So I can extend this to the left-hand side, continuing the same pattern. So negative pi over 2 would be negative 6. Negative pi would be 0. 3 pi over 2 would be 6. And negative 2 pi would be 0. And then we can connect the dots. All right. So we know that this is our period, 2 pi. and our amplitude is 6, which is half the distance between the maximum and the minimum. Alrighty, let's do the next one. So we have here y equals 1/2 cosine x. So our amplitude here will be the absolute value of 1/2, which is 1/2. Our period will be 2 pi divided by the absolute value of b, which is 1. So our period is 2 pi. And the parent function for cosine x has a period of 2 pi. All right, so the only change in our parent function of our graph is going to be the amplitude. So instead of the amplitude being 1, it's now going to be 1/2. And we know that the cosine graph starts at 0, 1 for our y-intercept, but instead of it being at 1, it's now going to be at 1/2. So 1/2, and then we go to 0, and then 1/2, 0, 1/2. So we can connect the dots here. Okay, and we can extend it to the left-hand side. So negative pi over 2 be 0, then 1/2, 0, then 1/2. Okay. So we see here that our period is 2 pi, and then our amplitude, A, is 1/2. All right. Okay, next we have y equals sine pi over 2x. So our amplitude here is going to be 1. The period is going to be 2 pi divided by the absolute value of b, which is pi over 2. So when we divide this, we will get 4. Okay. So we know that one complete cycle for the sine graph is going to take place within 4 units. Okay. So my y-axis here goes by 2, so I'm going to set my x-axis to also go by 2 here. So make this 2, this 4, make this -2, and make this -4. All right, so now let's plot our points. So we know the sine, one complete cycle of the sine graph will happen within 4 units, not 2 units. All right, so we will start at 0, and then we will go to 1, because our amplitude is 1 at pi over 2, then 0, then -1, and 0. And so that is one complete cycle of the sine graph that happens within 4 units. We can then extend this to the left-hand side. So -1, 0, 1, 0. All right. So we know our period is 4, and then our amplitude is 1. Okay, well actually this went too far. Let's fix that. There we go, it stops right there. Okay, all right, let's do another one. All right, y equals cosine pi x. So our amplitude, let's erase these little scribbles. Our amplitude equals absolute value of 1, which is 1. Our period equals 2 pi divided by the absolute value of b, which is pi. And so our period equals 2. So our y-axis here goes by 2. Our x-axis, we'll just keep the same scale like we did on the last problem. It's going to go by 2. Now the cosine graph must complete one cycle within 2 units. Oops, that's not what I wanted. So I'll label the cycle here, one complete cycle. Okay, so the whole cosine. So we're going to compress it. And our amplitude is 1, so that hasn't changed. So we're going to start at 1. Cosine starts at the y-intercept. And we must end at 1 for 2. So halfway in the middle is going to drop to 1, and then this will be 0 and 0. That way, we have one complete cycle within 2 units. So now we can continue this pattern to the rest of our graph. So 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0, 1. And then we can put an arrow and then connect these dots as well. All right. Cool. All right, number 5. Y equals 1/2 cosine 3x. So now we have a changed amplitude and period. So the amplitude equals the absolute value of 1/2, which equals 1/2. The period equals 2 pi divided by the absolute value of b, which is 3. So the period is pi over 3. So that means one complete cycle of the cosine graph is happening within 2 pi over 3. Okay, so my graph here goes by pi over 4. So what I'm going to do is just label where increments of pi over 3 would be. And that would be over just a little bit more. So I'm breaking it into thirds. On both sides. Okay. All right, so now it's going by thirds, and then this will be the third mark. Okay. All right. So we know that 2 pi over 3, so this is pi over 3, 2 pi over 3, and then 3 pi over 3 would get us pi. So this is going to be the period that the whole one complete cycle of the cosine graph must complete. So we know that the amplitude's a half, so instead of starting at 1, we're going to start at a half. I'm going to start at a half. And we know we must end at a half for a complete cycle. Okay. So then right in the middle would be the halfway mark, which would be -1/2. And then if we were to do halfway between pi over 3 and 0, it would be pi over 6, which would be 0, and 0 over here too. So then we can connect these dots. And that would be one complete cycle. So now let's extend this to complete all the way to 2 pi and then to -2 pi. Okay. So continuing on from 1/2, all right, we go to 0 and then -1/2, 0, 1/2. Oops, that looks more like 3/4. 1/2, there we go. And 0, -1/2, 0, 1/2. All right. So I would be able to complete 3 full cycles between 0 and 2 pi. So I'll extend it to the other side of x equals 0. So 0, -1/2, 0, 1/2, 0, -1/2, 0, 1/2, 0, -1/2, 0, 1/2. Okay. All right. And that is the graph of y equals 1/2 cosine 3x. All right, number 6. So our amplitude here will equal 3, because if we take the absolute value of -3, we'll get 3. Because it's negative, though, we know that we are going to reflect over the x-axis. Okay. The period equals 2 pi divided by the absolute value of b, which is 2. So our period is pi. Okay. So we will complete a full cycle within pi. All right, and we're dealing with the sine graph. So our amplitude is 3. So instead of going to 1, we're going to be going to 3. And then it's reflected over the x-axis. So since the sine graph starts at 0, 0 for a complete cycle and goes up to 1, we now will be going down to 3. So we're going in the opposite direction. So let's do one complete cycle. All right, so we know, let's get my colors here. We start at 0, 0. Okay, and then we would go up to 1, but because we're reflected, we would go down to 1. But our amplitude is not 1, it's 3, so we're going to actually go all the way down to 3. Now, we would have placed it at pi over 2, but since we're compressing it, because our whole complete cycle has to be completed within pi, we're now going to be going to pi over 4 all the way down to -3. Okay, and then we would go up to 0, then up to 3, and then back down to pi. Okay, so this right here will be one complete cycle of the sine graph. Okay, and now we can extend this to the rest following the same pattern. So we go to -3, and 0, then 3, then 0. Now on the other side, we will go to 3, then 0, then 3, 0, -3, then 0. Then we would go to +3 to 0 to -3 to 0. All right. So let's connect our dots, make our smooth curve. All right. And that is our graph. Okay. That concludes section 4.2.